What is Amazon Bedrock? And why we are discussing about the Amazon Bedrock, we'll explore that. So, Amazon Bedrock is nothing but a fully managed service that has been provided by the AWS, okay, which runs on the foundational models basically. So the foundational models are provided by the different leading companies who are in artificial intelligence. They have been provided on the Bedrock platform, and then through the Bedrock you can explore it. Okay. So foundation models are basically they are the large models which are trained on the predefined data set or a large data set basically, and which has various tasks which they can perform, like including text generation, the translation, code completion, and even the image generation. Okay, and even the summaries. Okay, so what does Bedrock do over here? So there are foundation models and there is a Bedrock. So Bedrock works as an API gateway for you. Okay, so it provides an APIs through which you communicate to the models, you pass your prompts, you pass the data to your model, and then it analyzes the data and generates the results for you. Okay, you don't have to manage any infrastructure over here. The Bedrock takes care of that for you. Okay, you don't have to host the models. Okay, models are there. You have to just get access for it and then explore it through the APIs. Also, Amazon provides the a very good playground to play around with. Okay, before you jump in into even the APIs. Okay, we'll get to it later on. Okay. So with the Amazon Bedrock serverless experience, okay, you can also even customize the FMs or the foundational models, okay, with your own data, or we call it as a fine tuning, okay, and then you can easily query your fine-tuned data from the custom models, and you can get the results that you are expected out of it. So foundational models may not be knowing everything that you want. It knows the public data. It's well trained on the public data, and it can give you the response for a public data. And wherein you want the custom solutions to be built on your data, that's where the fine tuning or the customization to the models comes into picture. Okay, so it's easy to integrate and deploy into the applications. We'll discuss this in depth with the demos, how it is easy to deploy into your applications. Okay, so let's go next. Why do we need a Bedrock, or why do we prefer a Bedrock? Okay, so as I said, so you get a foundational models from leading AI companies like Anthropic, Cohere, Meta, Mistral AI, Stability AI, and Amazon itself have their this thing models. Okay, and Amazon Bedrock provides through it API for you. Okay, so you can easily experiment and evaluate these FMs for your use cases, and you can easily decide upon which use cases, which model suits best for your use case, and then you can go take it forward from there. Okay, you can privately customize these models using the techniques such as I mentioned, fine tuning, and there is also called as retrieval augmented generation, which is RAG. Okay, so basically RAG is nothing but the you have tons of documents of data. Okay, you want to retrieve the data from those this thing or the whole the corpus of a data, okay, you have, and you want to get the text out of it, or you want to do certain kind of analysis, you can do using the RAG basically. Okay, so Bedrock is serverless and you don't have to manage any infrastructure. Securely you can integrate and deploy, and that's the best part of a Bedrock. Okay, it allows you there is a data security also, which is very high concern for the people nowadays. Their data is not getting leaked or not moving outside of model basically, or to the outside people. So let's go forward and look into the models. Okay, so there are these kind of models. All these models are currently available on Amazon, but not on all the regions. US West 2 has all the models. Okay, you can request another US West 2 region. This region supports all these models. Okay, so let's talk about the first Amazon Titan. So Amazon Titan has the two kinds of models. One is a light and the one is a express model. Okay, with other different capabilities and a vast training data set. Okay, with that they have been trained on. The other models which has been provided by the other AI companies like Anthropic, Cloudy, then Command and Embed, Jurassic, Llama, Mistral AI, and Stable Diffusion. Amazon Titan models also supports the image generation as well. Rest of the models mostly not, other than the Stable Diffusion. We have a Stable Diffusion XL, okay, two versions wherein we do the image generation. Rest of the models have kind of a similar kind of the what we say the capabilities, but with some distinctions. As we Some models are very good in answering Q&A, okay, question and answering, kind of a building of a chat model, chat application. They are very good in it. And cloudy model is something which is built on conversational AI. Okay, so what is conversational AI is a harmless training that they do. Okay, so we'll go in depth into that. First, we'll look at the Amazon Titan, what it offers to us. So Amazon Titan is a very used model by Amazon clients basically. Okay, the different clients are using it. Okay, so you have a very high performing imaging model with them. The textual model choices you have within the Light and Express version with the fully managed API. You just call an API, pass the model ID and your prompt, and it gives you the database on it. Okay. So this is created by AWS and the pre-trained on a large data set by AWS. So this is owned by AWS, and you can use it easily. Okay, so all these models you don't have a separate APIs. That's a one good thing. Okay, so within a single API you can call any model. Basically, you have to just change the model ID. In a while we are going to see it. What are the use cases of this model? Is it good for a content generation, for blog posts, classifying articles? So one question always comes is that why do we use these models? Why do we use the AI? We are solving here the day-to-day life problems, and when it comes to the development, or you have a lot of problems in your society, so like classification problems as we deal with, and then some kind of regression problems we deal with. Okay, so let's consider an example like you want to classify the articles. It's very difficult for a person to sit and put a tags for categories for the articles to which category it belongs. So just imagine passing the content article to the model, and then the model predicts you the categories to which it needs to be tagged. So much of automation happens there. So these are the use cases which the models gives you. Okay, you can summarize the long documents. As I said, the articles, you can generate the summary out of it. Okay, like say if you want to read a textbook and get something out of it, then you don't have to read it all the way down like 500 pages or 400 pages, right? You can just pass it to model can give you the in detail summary of about it. Same goes for the technical papers. When you publish any papers or the research papers, you of course do the literature survey over there, and then you need to know what the previous technical papers, what are they are saying basically, or what people have published. Then you need to come up with something of your own. So you need to go through like tons of papers over there, like 10 to 20 papers over there, and then it really becomes difficult. So that's where the help comes in. So the next is the image generation part, wherein the the market is very much using the image generation. So just consider e-commerce application wherein the let's say any vendor basically who has a e-commerce business wants to put images for a product. Like you have obviously 4 to 5 images for a product, and then you just imagine these images one designer is going to create. It takes a lot of time. Instead of that, you pass what kind of image you want, and it's going to generate an image, and your just job is to publish them. So it becomes that much easier, even for the business owners to get this done. Okay, so you can deliver more up to date and accurate results using these FMs and train your own data sources. So when we say own data sources, it could be the data which is there in the CSV format, or it could be in the data which is in the JSON format. Okay, any kind of a format data, formatted data, or even the unclassified data or unlabeled data, what you can say. So the model can perform the analysis on it, and you can do the fine tuning, and you can get the results. So let's move on to the next model that we have is Anthropic's cloud. I won't cover all of the models. I'll just cover the three. Most of them have the similar the functionalities basically. Okay. Now this is the industry leading model with the 200K tokens. Okay. So you can imagine like translating them into the 150,000 words. Okay. So and which is approximately 500 pages. Okay, it could be less or more than that as well. Okay, so just an approximation. Okay, so what this is useful for, it is useful for technical documentation. You upload your technical documentation like your entire code bases, your financial statements, or even the long literature work, as I mentioned before. Okay, so and you can get an analysis of it. Okay, the financial statement you upload and you ask the model, okay, in which month of the year did my finances go down or go up? Okay, and why these models we are using is for the forecasting, so that we don't face the same situation in the future. Basically, like say I have a e-commerce business, and my business goes down in the month of May. I analyze it, so that I take a precaution in the next upcoming year. I don't do the same mistakes, or I do something better which will make my sales revenue go up in the month of May. Okay, so it also helps you in a forecasting. So the main thing what is models are used for forecasting actually. Okay, and analyzing your previous the database. So let's go forward. So it can summarize, perform Q&A for you, and forecast trends, as I said. Okay, compare and contrast multiple documents. Okay, so like you have a survey papers, and then you want to compare what the people differently they have done. Okay, because if you like build a convolution, if you want to go and build a convolution neural network or research scholar, and then you want to do the research on over the past papers, all of the what all of the people have done or the research scholars have done, so you're just going to compare and contrast it, and you're going to get a summary out of it of what they have done and what you can come up with. Okay, so yeah, so it can also read, edit, rewrite, summarize, classify to solve the classification problems, extract the structured data, as I mentioned, JSON format, XML format, HTML format, any data that you source you pass. Okay, as I said, Cloudy is trained on a harmless training. Basically, it is done through the harmless training. What is meant by harmless training? It's like the humans, like if you train it to like put some unfiltered keywords or the filtered keywords, like killing someone or something like that, it's not going to take it. Okay, so that is called as constitutional AI. They are going to they consider always the human safety in it. Okay, and the safety research data has been provided, so no such data has been trained. They call it as a moderation. Whenever you train the data, you do the moderation before you train the data and classify this data in which category it falls actually. Okay, so let's go forward. The last model that I would cover is a stable diffusion Excel. Now this is the one of the best model for image generation. There are different models provided by Stable Diffusion. It's actually provided by Stability AI. The model is called a Stable Diffusion. Okay, one is the writer version and one is the Excel version. Okay, so it can generate a different kind of images for you, but images are of a same size. Width and height should be the same. Maximum is 1024 512 by 512 also it can generate. Okay, and you can basically use it for the this cinematic uh, for embedding the scenes and the fine details with the editing tool and all. Okay, so you can fine tune to create a complex composition with basic natural language prompting. So you just put a prompt and then you can generate an image. With an image, again, if you want some changes, let's say you have generated an image with the red sofa in the room and with some lighting, and you get an image and it has a curtains in a red color, so you don't want a curtains in a red color. You will refine your prompt and then you are going to say, okay, I want a curtains in a blue color. So that's how the fine tuning or the natural language prompting works. Okay. As we see, the use cases are very much obvious. Advertising and marketing can save a lot of time for the business owners, and of course, you can do the media and in the media and the entertainment world. You can definitely use it. Okay. So let's head over to the one of the demo that I wanted to show you all. Okay. Okay. So we'll see first Amazon Titan. So as we speak about the serverless as well, we have done it with a serverless. Okay. Just let me enlarge the screen. Okay. Okay. So I hope you guys can see the screen. Okay. Before this, let me go to the Bedrock. So you can log in into the your AWS console and you can go to the Amazon Bedrock. So just type in Bedrock and you will go to the Amazon Bedrock. The first and foremost thing that you need to do, you can go through the whole of the documentation when you have start exploring it. The first thing you need to go to the model access. So I'm currently in Oregano, so it's in US West too, and it has all the access to the all the models basically. Okay. So what you need to do is manage model access. You need to click, and then you select whichever one you want. So currently I have these three with me, and then you say, if you let's say I want this, you say save changes, and then it's going to in some time it's going to give you the access for it. So right now I have made access to these three. So now let's go. They have given the examples and the overview about it. You can also go over there. There are providers which I told you. Amazon, Anthropic, Cohere, Stability AI, and all of the details are available here in depth of what the LLM does or the foundational model does. You can explore it over here. One good thing is they give you the request which needs to be parts to the Amazon Bedrock API. You can take this for each of the model they give you, okay, and then you can use it in your code. Okay, now this Amazon Bedrock is the fully managed on-demand service. That's why we call it as a serverless. And then okay, now we'll see as we see in this the payload and how do we get access to this. We'll come back to this later. We'll see how we can use it in our development environment. Okay, so I'll straight head over to the Lambda. So I've created this Lambda. So when you create a Lambda, you make sure environment which I'm using is a Python, and don't make use of a Python 3.9 version. It doesn't support the Bedrock runtime service. Please make use of 3.12 environment. Okay. So what I'm doing over here. So once you create a Lambda, what the first thing that you need to do is go to the configuration, go to the general configuration and edit it. And then you check for the role. So this role by default is going to have only the basic Lambda execution role. You need the access to the Bedrock. So you need to go over here. So open that role and you can go to the add policies. So only you will see this particular the role. permission, sorry. So, and you can add the permission. So I have added the Amazon Bedrock full access permission. So you can attach policies directly from here. Okay. So since I've added this, my Lambda should be able to call. Okay. So, and of course, increase the timeout. It is just 3 seconds initially. You make it, I just made it 1 minute, 3 second maximum is 15 minutes. And depending upon your requirement, you adjust the memory as per your need. Maximum is 1024 MB that you can support from the Lambda. Okay, so let's head over back to the code. Okay, so let's deep dive into the code. So this is the normal Lambda handler which the Lambda gives you. So the Boto3 is the library which the Amazon provides you. Okay, the SDK provided by the Amazon for the Python for all the AWS services that we are going to use. So the Boto3 client, you need to put a Bedrock runtime over here, and the region in which we have invoked our this thing, the models access is in US West 2, and the Lambda is also in the US West 2. So you need not even specify this. If you want, you can specify if you're connecting to some different region Lambda, different region model basically. Okay, then you can specify different one over here. So let's see the Lambda handler code. So in from I'm extracting a prompt from the event from the prompt. Okay. So I have configured a test event in which I am entering my prompt. I'm getting that prompt. Then keyword arguments I am constructing over here. Okay, as a dictionary format, and then it unpacks. So the model ID goes as a model Amazon Titan. So this is given by Amazon Bedrock to you. Okay, so which I said, which I shown earlier in the console. Then content type is application JSON, which is sending. What you're going to accept, this is all content types which I've put, or you can put application JSON as well. Okay. Now the main part is the body. This has to be the string, so that's why we need to dump this as a string. Okay. So because it's the application JSON. Okay. So this dictionary will get converted into basically the JSON string. So you need to provide an input text. Okay. You don't need this always. I'll tell you why do you need it. Okay. So input text is the prompt. Okay. So whatever is your prompt will go as an input text, and the text generation config, okay, is something that you need to play around with. Okay. So remember that Titan gives you the max of 884 counts. Okay. Combining your input counts and the output counts. Okay. Now, if your result suffices between these both, you will get the result. Otherwise, you are going to get the cutoff result. Okay. And the reason would be the this thing, the completion is not finished. Okay. Limit has been reached. Now, if you want a particular token size results, okay, so I want 250 tokens to be generated, and one token constitute of around 4 characters. Okay, so I want 250 this thing, the size of the output tokens maybe. Okay, the temperature is something you're going to play with. This temperature concepts remains the same across the models. Okay, this is how a dynamic result you want. Okay, from 0 to 1 it varies. Okay, so from 0 to 1 you can pass any value. The most stable value that a model has found out is a 0.7 and above than that. Okay, wherein you want the dynamic responses to come into picture. There's another filter which is called as top p. Okay, so top p is a filter which allows you to decide the next token which is going to get generated when the model is going to generate an output for you. Okay, so whenever the modeler does the generation, it makes the use of top p parameter and decides what should be the next token coming for you, how closely it should be to the previous token and the previous text generated basically. Okay, so you can play around with it, and then you just need to call a invoke model function, and you need to unpack this keyword arguments directly over here with two asterisk symbols. It's going to unpack and then it's going to pass it to the client, Bedrock client. So depending upon which model you configured over here, it's going to call that model. Okay, and then it's going to give you the response. Now remember that response directly you cannot read the data, so it means you're not going to get directly the output. Okay, it will be a streaming body which will be how the stream comes of a data. The same way it's going to stream it down to you. Okay, so all thing that you need to do is from the response you need to get the body out of this. Okay, and from the body you're going to apply a read function that is going to give you the data. Okay, so I loaded in the JSON format and inside a body. So some things I'm outputting from this body, that is input text token. So when my input has gone, what was my tokens out of those input? What are the result token count? So whenever the result generated, how many token it had? What is the actual output text? What it gave me? And the completion reason why it got completed, whether it finished successfully or not finished successfully. Okay, and this is just the normal response from the Lambda. Okay, so let's test it out. Okay, so I need to configure my test event. So I have already configured one. So what I've done in the prompt, I have passed a meeting summary. This is an useful application wherein you pass your meeting summary and you get the things out of what is happened on that meeting basically. Okay, what did the people discuss over that meeting? So now this is the prompt which I passed about a one kickoff meeting happening about one project. Okay, the different entities which are involved over here, like project manager, developer, okay, and the client and the server person. Okay, so all this the data which is there over here is a conversation between all the entities that happened over the call. Okay, so this is a transcript you can in a way you can consider. And at the end, what I tell them, what I tell them, my prompt is please generate a summary out of it. Okay, so let me just show you that as well. Okay, so my transcript ends over here, end of meeting transcript, and I'm asking briefly summarize the above meeting transcript. Okay, so this is my the whole transcript that I have. Okay, so let me remove this, and this is my prompt. So just to elaborate, I've shown it all that way. So let me save this and let me test it. So configure test event is this. Okay, so it has tested. So let's watch it out. Better in a CloudWatch maybe. So input text token count is 756. So whatever input I have given in the prompt is 756 tokens. Whatever they the returned me, the model returned me is 142. Okay, the token output text is this. Okay, the completion reason is finish over here. Now since we'll look into this part what it has written. So what I've outputted over here is a completion reason. Okay, what I have done is I have asked for 250 tokens in the output. This is in the output, remember, not the input plus output. Okay, so it has sufficed within 142. So if I had put like 100 counts, the finish reason would have been different. Okay, let's look at a CloudWatch log. What I have logged over there. So okay, sorry, go to monitor. Okay, so let's look at the CloudWatch logs. Took a bit of time. Okay, so if you look at this we have already seen. So it gave me an answer over here. The kickoff meeting for the Node.js application project held between the Alan Johnson, Jack, and Kevin, representing XYZ Corporation. So I did not mention the corporation over there. So Johnson provided an overview with the requirement, including web phrase application with the user authentication, all of the schemes. Okay. So it gave me a brief of the short summary, what had happened on that client call. Okay. Now I don't have to go and listen to the recording of the client call, right? So this is a very good application wherein and the whoever has missed this meeting or the new developer who has comes in on this project onboarding can directly look at this meeting, this summary, and can look at it, what happened on that time. So the completion region is finished region. Okay. So there are certain these things, what we say, the completion regions, why these things are failing. Okay. Let me show you all one. This was a topic. Okay, so here we go. So my result token was count was just 100. Okay. So when we were experimenting this, so if you see the completion region is length over here, it's not finish. That's why uh, if you look at this, I've got only half the thing. The meeting concludes with everyone expressing excitement and the further things did not came. That means the length hit it and then I was not able to move forward with this. Okay. So it's very important how you play with the tokens that you want in your output. So consider it's always higher, okay? And because you don't miss out on the actual data, exactly. So this was regarding the Amazon Titan model. The briefly, I'll give you the demo of image model as well, okay? Won't take much time. So let's head back to another Lambda function. The settings remains the same. You need to get access for the image generation model, and basically you need to configure it. So yeah, let's go ahead. So as we have seen all these things, then okay, a Bedrock runtime we have seen. Okay, we are considering the S3 resource over here just to upload the image back to the S3, the fetched image from the model. So the bucket which I've created is an inbound stable diffusion. I'm just naming the file with a test.png. Let's look at the keyword arguments. The API is going to remain the same, invoke model. So keyword arguments model will remain stable diffusion XL v1, since this is the one which I made access for. And this parameters remains the same as we have seen in the previous Lambda. And the text prompt, so this body changes. Okay, you need to give a prompt, you need to give a weight, how many samples you would need from the stable diffusion. And then FCG scale and the step is there. Okay, we are going to come to this. What is FCG scale and what are steps? You need to give the width and the height of the image that you need. 1024 is the maximum that you can give. And then you need to invoke the model. It's going to give you the data. Now the response body is a little different. So from the body, you're going to get a result, whether it's a success or not. Okay. From the this thing body, actual the image that you want, you will get it from the artifacts. From the artifacts, how many this thing images you are querying, there's many arrays will come over here. Of zero, you need to fetch the base 64. So image will be in a base 64 image format. Okay. The finish region you will come to know by looking at artifacts. First image in the finish region. Take this base 64 image. Okay, put it wherever you want. Now, for example, I'm putting it in the S3. Okay, so I took the S3 client and the bucket name and the file name with the object needs to be created. And then I'm putting using a put function, and the body is set to the this base64 image. I'm using base64 library. I'm decoding it and passing it to the S3 object put function. Okay, so this will create an object inside the S3. So let's go ahead and test it out. Let me clear if there is any test file should be there. Yeah. So let me delete this. If it is there, it's even going to basically um, overwrite it. Okay, so you got. So let me test this out. Okay, let me check the test event that I've configured. Okay, a room with a good lighting, sofa, and a lamps. Okay, so let's run this only. Okay, so it has run successfully. Let me check the S3 bucket. Okay, so the test file has come in at 570. Okay, IST. So let me download this. Okay, so it is downloaded. May open it. Okay, so this is something wrong which is come in. So we'll regenerate it again. Okay, so let me refine the prompt or provide a seed value actually. Yeah. Let me see the new image. Yes, so this is come proper. Okay. So, yeah, so what the prompt I've said, the sofa with the light and the lamps basically. So that has come into picture over here. Okay. So you can always refine your image prompts. Okay. This I've given the one example of this Lambda over here. You can first, before jumping into the Lambda, you can always go to the playground. So there is a nice playground which is provided by the AWS for the chat, text, and images. Okay, this is for the chat. Okay, and then you need to select your model. So whichever model you have picked, picked the Amazon, so you will get to select this, and then you need to apply this. You put your prompt over here, and then it's going to generate a text for you or classify a text for you, whichever whatever you want. Okay. And then you have all the parameters which we configured in the API. Okay, top P, the temperature parameter. Okay, and then you have also a text playground over here to play with the different models. You have an image also. You can generate the images from here, from the model, this one. The most important is the custom modules. Okay, so what you guys can do now is, you know, the in-depth how the foundational model works now. Okay, you can explore more. Okay, and you can create your own models. So basically you can go to the custom model, create fine-tuning job or create continued pre-training jobs. Okay, so on top of the foundational models you can build your model or from the scratch basically with the fine-tuning jobs. So if you say create fine tune job, it's going to ask you to select your model which you have actually subscribed for, and then you can apply from here. And job configuration, you can put the input data which is a S3 bucket URL for the file. Okay, you can put a validation data set. Okay, the testing data set and the training data set, you can this thing change it. If you are well versed with convolution neural network, and you will come to know what is epochs. Okay, the number of times the model is going to look at your data while training. Okay, the learning rate. Okay, so these are all technical terms. You can before exploring into this, going into this, I would highly recommend you all to go into the machine learning concepts. What the epoch means, what are the base sizes, what is the training test set, validation set. Okay, so this is a knowledge base that you need for custom models. So you can start off with the foundational models and then learn more about the deep learning and the machine learning concepts, and then jump over on this. Okay. So let's head back to the presentation. This was the short demo. So yeah, so a nice application that I have given over here is the client call, which I said. So now the one that I've given in the Lambda. So just imagine the client call is done. Okay, you are recording the one person needs to upload a project manager, project coordinator to S3 bucket. S3 bucket will trigger the Lambda automatically. It will take that MP3 file. It's going to use two services. This one I did not use since I had a direct text. Amazon Transcribe will convert the audio MP3 file into the text, and the text will go to the Amazon Bedrock. Bedrock will give you the text summary. So just imagine this application coming into your Zoom or some other this thing you're going to do, the application that you're using to communicate with the clients, and then you get a summary out of it. So it can save a lot of time for you. The question comes for the data protection. So data protection, so the all the model providers, they are provided with the escrow account, okay, which is basically the private to them, and nothing has to do with the models. Okay, so only thing what they do is over here is they just upload their models. Okay, and then the models communicate with you, but they don't have access to the communication what you are doing with the model. Okay, so Amazon Bedrock does not use your prompts or continuation for the AWS models for or distribute them to the third party providers basically. Okay, so SROC account which is there, okay, so it has a rules basically. Okay, so SROC account themselves don't have outbound permissions. Okay, so there is a Amazon Bedrock account and there is a SROC account which the clients are using and uploading their models, and then the model comes into the Amazon Bedrock account which they don't have access to. Okay, so whatever the communication happens or the whatever the querying things happens is remains secure. Okay, along with that, your queries, your prompts are never been logged by the Amazon. Okay, neither in the service logs nor in the custom logs, basically. Okay, so that's all about the this thing. So you don't have to worry about the data. Data also remains in your region. It doesn't go out of the region that you are using.